Hello again. In this video we're going to look at Constexpr and Lambda expressions. In C++ 14, Lambda expressions could not be Constexpr. If you try to write code like this, you'll get an error saying that your Lambda is not a literal. In C++ 17 we can now use lambdas at compile time. We put the Constexpr keyword after the function argument, and that'll make it a Constexpr lambda. For this to work, any captured variables must all be constant expressions, and the function body must be something that can be evaluated at compile time. So here is that lambda expression. We are not capturing any variables, and this body could be evaluated at compile time. We have this static assert which is going to call the lambda at compile time. This is all part of the compilation process, and it'll check the return value. And if the lambda does not return the expected value, then this will terminate the compilation. So that compiles. If I change this to true, then we get a compile time assertion failure. So the lambda is being called at compile time. In fact, we do not actually need to provide this Constexpr keyword. We can leave it out, and provided all the other requirements are met, then the lambda will be regarded as Constexpr. So lambdas can be implicitly Constexpr. And just to demonstrate that, it still compiles. We can also use Constexpr if with lambda expressions in the body of the expression. All the expressions in the if statement need to be constant expressions. So we could have code like this, and we'll get the usual behavior. Only the branch which is taken will remain in the source code, and the other branches will be ignored by the compiler. Unfortunately, Visual C++ does not support this feature. We get a strange error about accessing a variable outside its lifetime. So let's try G++. And no problems there. And this will work with all lambda expressions, not just with ones which are Constexpr. If we, for example, capture a variable which is not a constant expression, then this lambda cannot be Constexpr. And we also have a side effect in the lambda, so that's two reasons why this is not a constant expression. And again, Visual C++ will not take that code, but it works with G++. Okay, so that's it for this video. I'll see you next time, but until then, keep coding.